Thanks everyone for coming. Yeah, mic is working. I hear myself. That's good. Excellent. Well, I'm glad that you choose to take the time after lunch and before your flight to come to us. You care about security. That's good. The good ones. Excellent. So we are three. We are all coming from the product group, working with security features. So I brought two colleagues here, and we will show you our newest features that we are working on in the space of Azure SQL and also SQL Server. All right, this slide you should know by now. That one probably as well, right? If you have not caught up yet, check online. There's plenty of other opportunities to learn after you're done with this summit, right? No need to wait until next year. You can keep learning in between. That's the idea. And that's the agenda for this talk. All right. We're going to start with the topic always encrypted with secure enclaves, which is new in SQL Server 2019, just been G8 this year. So it's basically new right now as we are talking. And then we're going to have some other features like private link for Azure SQL Database, Azure Active Directory migration support, data classification and discovery, and advanced data security. Okay. So, always encrypted with secure enclaves. As I said, this is now for SQL Server 2019, meaning this is not for Azure SQL Database. For Azure SQL Database, we still have the always encrypted without secure enclaves. Right? It's just called always encrypted. This is the version that is existing and has been in the product in SQL Server 2016, 17, and obviously still in Azure SQL Database. Who of you is familiar with always encrypted? Okay, well, that's almost everybody. And who has actually been using it in production? Not just seen it and, oh, well, that's not everybody. I think like 3 hands now, as opposed to the whole room before. Okay. So you know about it, just more point out the key factor here. So the idea here is that using this feature, we can make sure that the DBA, the owner of the SQL Server, anyone who is owning actually the whole box of where the machine is running, like even the Windows administrator, will never have a chance to gain access to the data in plain text. That's the idea of this feature. And to enable that, we have implemented in a way that the encryption already happens in the client as well as the decryption. So the client in this diagram on the left side with this green box, that's the client. He will use an enhanced driver version and where the encryption and the decryption will take place. So the encrypted data will be sent to SQL Server. There it will be stored. When the client needs the data, selects data from a very table in SQL Server, SQL Server will send the encrypted data, but it gets decrypted in the client driver and then shown clear text to the end user on this machine. This means that a SQL Server administrator who is working on the box of SQL Server using Management Studio or whatever will not be able to see the data in plain text. Right? You can see that it is encrypted. He can select from the table because he has the powers to do that, but he does not have access to the key that encrypts or decrypts the data. And this is why you cannot see it, right? That's the whole idea. So making sure that the data is encrypted and decrypted outside of SQL Server, and that basically takes away these powers from whoever owns the machine. Now, this can not only be a local on-prem machine, it can also be us, right, running Azure. So Microsoft does not have a chance to see your data if anyone should force us to do so. I don't know who could be that, right? Some government agency. Well, even if they fine us, there is no way we can decrypt the data because you have the key. You decide to keep your key, you just send the data, the encrypted data to us. That's the idea of always encrypted. It has certain limitations. So obviously, since the data is encrypted, and if we now task SQL Server and say, okay, give me some data, and I only want the row where where a certain order entry has been made by Smith, as long as it's a deterministic comparison, this even works, right? Because we can make the encryption of the value Smith in the client, send the encrypted Smith to SQL Server. He will compare it and find, okay, well, I can't read what it is, but I can show you that this encrypted binary here is the same as in this table, and I send you back this encrypted row. Client knows, well, that's the row of Smith, and decrypts the rest of it, and he gets the data. So with equality comparison, this works fine, and some other operations. But when it comes to more complex operations, like, well, give me anything that, any order that was done by a customer who starts with the letter S or something like that, that's not doable because of the encrypted value. We cannot take parts of that. SQL Server doesn't know anything about that. So that's the limitation of the existing always encrypted version that we have already. Okay, so more complex operations. Another challenge is, let's say your data already exists, right? It existed before SQL Server 2016, and you now want to use this feature and encrypt all your data. Since this feature works in a way that you have to decrypt the data outside of the box, that means potentially up to 1 terabyte of data or whatever you have, you need to send to the client, decrypt it there, and send it back to SQL Server. Now, that's not a big deal if your database is like 20 megabytes or 200, but if you actually have 2 terabyte or something even close to that, it's gonna take a long, long time. So that is a big issue for customers to even start using encryption. And that's what we're trying to tackle with always encrypted and secure enclaves. So this is basically the solution, what we're bringing now in SQL Server 2019. We have found a new way how to handle secure encryption, keep it secure away from the DBA, and still do rich computing and also solve the data load issue. So the essence here is that we have a so-called secure enclave that sits in memory of the SQL Server box. Inside of this memory region, which is protected, we can do anything with this data basically because we are decrypting the data inside the enclave. Inside the enclave, so meaning, well, it's on the box where the administrator potentially has full power, but this enclaving technology allows us to guarantee basically that nobody can get to the memory region. This is an enclaving, that's the key of enclaving technology. It's really a protected region that lives on the same box, but no matter what permissions you have, you cannot get inside, even as an administrator of the machine. I'm gonna talk about this a little bit in the upcoming slides. So now what does this enable us? Since we now have this special memory region, which is on the same box as SQL Server, obviously, that first of all means we don't necessarily have to send the data back and forth for every operation. We can just do it on the box, saves us some time, right? So the aspect of in-place encryption versus we have to move the terabyte to the client and encrypt it there and send it back, that's solved with this technology because we can do it in the enclave, no network round trip, right? So we encrypt the data inside the enclave, keep it on box, and then store it in the local SQL Server in the pages. So no round trip there. And also it enables us to do rich queries, anything, also rich means basically anything like, right? So we can say pattern matching, as I said, Smith, or anyone starting with a certain letter, or range queries. That's possible now because basically inside the enclave data gets decrypted, and now we could potentially do anything with it. I'm saying potentially, and I will come to that, right? So, but we definitely support right now like and range queries. So you can actually say, give me any order that has been placed by a customer starting with a certain letter, yeah? Because we can decrypt it inside the enclave and then based on that figure out any rows. Okay. So what exactly is this enclave? So as I said, it really lives on the box of SQL Server. It's an isolated, protected region of memory. Nobody can access the data that's inside the enclave. There is only a certain channel to send data inside the enclave, where it can now work with the data, but you cannot interactively just say open a session and let me see what's in there. inside the enclave, and this is now the key point, to do operations like the like search or pattern matching, generate any other rich queries. Since I said we cannot look inside the enclave from outside, so SQL Server cannot just say, okay, here's the enclave, let me break in and do my fancy queries because I know I have the query processor, let me do that. No, that's not how it works. So any operation that has to be done inside the enclave has to be supported by code that sits inside the enclave. And that's the reason why we cannot right now support every query that exists in SQL Server, because we have to put all the logic, the operations, in now basically duplicate. Anything that SQL Server can do right now, we have to take this code, put it inside the enclave. Because the enclave is protected, there can be no interactive code access. I mean, that would enable a hacker to infiltrate it and run malicious code, obviously. So the only way to change code is basically source packs, right? Cumulative updates, but not interactively just coming up with new code. Right? So the code already exists inside the enclave once it's being created, and then it can work with this code on the data that's being sent inside. All right. Yeah, so this enclaving technology is nothing that we in itself invented. So enclaving is technology that you may find on your phone. Yeah, there are different names sometimes for the same principle. Even Apple uses that on its phone. Yeah. So it's just this principle of having a secure memory region that disallows any access from outside. Okay, I can't connect to my demo machine here, so I will just show it in slides and also save some time by that. So let's say you have a database and you have encrypted it. Actually, I can really briefly show you one example how to decrypt your data. The code has not really changed that much from the old version of all is encrypted. So it's order table, take your column that you want to encrypt, order column SSN, encrypt with a certain key. The type of encryption, randomized or deterministic. So in SQL 2016-17, you had to use deterministic in order to make an equalization search on this column. But now I'm using here randomized. And even on the randomized column, I will then be able to create an index even. I have not mentioned that yet. But basically, I'm saying we can even use randomized data and search on it. Right? That's the new big thing that we are supporting with the secure enclaves. It doesn't really matter what type of encryption. We're going to decrypt this anyway inside the enclave. And then we can do almost anything on it. Right? And then the algorithm, and we do it online. Yeah, so that's basically the command. So let's say we have encrypted a table like this, and we have an application that does a range search. Here's a little bit like a web front end where we have a slider producing a command like this, select SSN and other columns from table, where SSN like whatever type of string with %, wildcard, and salary greater than and smaller than certain values, right? These operations would not be supported in the old versions, always encrypted, right? And if we would now use extended events, let me see if I can zoom in here. Can you guys read it on the end and at the back row? I don't think so, right? No. Let me find Zoom real quick. Okay. Not too early. So if I were to create an extended event trace on this machine, just as an administrator, I can obviously try to get to the data, right? So the client machine sends the command with the parameters. That would be what would be on the unencrypted version, right? Before you even encrypt the data, you would see it obviously in clear text what has been sent by the application, right? If you trace it. So that's unencrypted. So now let's say we're using always encrypted, and here in the screenshot I'm showing that we have a special parameter in the connection string. We need to enable always encrypted, and also include an URL to the attestation service. I will talk about this a little bit later, but this is a feature of the enclaving technology. We need to point to this attestation service in order to make sure that the enclave is still trusted, right? So that's just a necessity in the connection. here I'm running the command that I just showed in SSMS, basically the encryption command. And now if the same select query comes on this table, not so good. Yeah. And if I now look at the extended event information, well, I can still see the query. It's searching for an SSN like at search pattern and min and max salary, but the search pattern here and the min and max salary, that's encrypted. It's being sent in an encrypted form already from the client. This is why on the SQL Server box you cannot see it. Okay? So, and this is being sent then to the enclave, and inside the enclave, both those values as well as the table values will be decrypted, and then we can find out, well, okay, who has this SSN in this that match the pattern. That's how it works. Okay, but the administrator has no way to look inside that. That's happening inside the enclave. And if the administrator were to be the Windows administrator and trying to be really sophisticated and using Windbg, well, you can do that. You can try to do that. So I used private symbols to that because it's not that easy to get to the region. But using private symbols, and I'm pointing it out with the orange marking there. I can unfortunately only show you part of that. Anything else is NDA, right? But trust me, so that there is a function call that contains the word enclave. Yeah, that's for real. So, and there's a pointer, this is the blue part. This is the pointer to the memory region. This memory region has the enclave, right? So I can use du dump me the memory region, which what I'm doing right now below here. And that's what I see. So the memory region is valid. Yeah? That's not the issue, but you cannot access it. Okay, so no way to get to the data. Internally, basically, there will be an access error, and Windbg swallows that and just gives you trash. Yeah. All right. So about this attestation, I showed you this URL. That's really important. I mean, here's an enclave, that's nice, but how do we really know that's trustworthy? Maybe somebody hacked the server and manipulated the enclave and stuff like that. Well, yeah, technically you can try to do that. It's not easy, but even if you attempt to do it, things will change. And we need to figure that out, that somebody's even trying to change some bits there, here and there. And this is why we have the attestation service. So we need to have an external entity. It cannot be the same box. Yeah? If you want to secure a certain machine, eventually we will come to the point that you realize you can always find a way to unwrap it if you own the whole box. Yeah? This is where you start to have to look outside. So we need some external entity that checks my machine, and in this case the enclave that sits inside the machine to make sure, well, it has not been tampered. Is it still the same signature that I expect, basically? And that's what's happening here. So the external attestation service is checking, has the enclave been tampered with? If yes, there will be information, and I think even the SQL Server shuts down. I think that was the state. Anyone from the team here can verify that? I think that was the case. I think even you cannot even use it anymore. You cannot access the data at all because now that there could be a potential infiltration. Maybe he didn't succeed to get in there. Maybe he's just trying, but still. In the moment that anything has been tampered, big alert, and we stop working there. Otherwise, well, if it has not been tampered with, then all cool. Just do your job, right? So that's the reason for this attestation service. And there's different attestation modes. There's a hardware mode and a host key mode. Basically, with the host key mode, we make it a little bit easier for you, so you can implement a test environment quite easily. Yeah. So you don't have to go all the way for the hardware mode, because the hardware mode basically means you should have its own Active Directory assigned to this machine running the HDS and in a certain mode, Bastion Active Directory for example. So it's a little bit extra work. If you really want to make 100% sure not even the attestation service has been tampered with, I mean, you have to go out a mile. Yeah, so you can do that. Yeah. But for testing, you're probably going to use the host key mode. It's not saying that host key mode is per se insecure. It's still very hard to get to crack that. Yeah? But depending on the security needs, you probably want to use the hardware mode. All right. Yeah, so this is just a slide about how do the keys even get there. So obviously the enclave, in order to decrypt or encrypt the data, he also needs the key. So there is a secure channel from the client to the enclave that he actually gives him the key, but not the SQL Server process. He gives it only inside the enclave and making sure that he's communicating with the correct enclave and not some man in the middle trying to get the key. There's obviously a secure protocol with key exchange being used. All right, I mentioned one thing, indexing. Now that's a big deal, right? Indexing encrypted data. I think that deserves an applause, doesn't it? I mean, the team worked really hard on that. Yeah, so we are the first database vendor that is able to do those things actually, to work on encrypted data and do complex operations and even index this data and obviously use the indexes, traverse them and to get your data quickly, right? I mean, if you have a terabyte data warehouse, all nicely encrypted, but super slow because you can't index it, well, you know the story, yeah? Security versus usability. So we're trying to make it useful. So this slide is trying to show you a little bit the complexity. When you have indexing, it's not just, okay, it's suddenly there. Somebody needs to be able to create the index, right? And well, the index is gonna be created using what? Using the encrypted values or the unencrypted values? What makes sense? I guess the non-encrypted values. But who is creating the index? Potentially it's the DBA. But hey, the DBA is what we're trying to protect against. So how could the DBA ever create an index if he doesn't have access to the key? That's what we want to prevent, right? So this is where we had to figure out something, and we came up with this concept of key caching. So basically, there is a cache in the enclave that contains the key. We already saw that in a former slide. So in the enclave can be the key. I'm saying can be because if the server just woke up, there will not be a key. But let's say if the server has already been running and somebody just ran one query, give me some encrypted value. In that moment, we have a key inside the enclave. So obviously, the DBA does not have access to the key because it's inside the enclave. Nobody has access, but it's there. So, and by having the key inside the enclave already, we can now enable the administrator to just say, yeah, run the command create index. Sorry, Paul, you still can't see the data, but the enclave does the work for you, right? He has access to the key. You don't need the key. The enclave does the operation, right? So that's how we enable that even a DBA with no access to the key can create an index. Okay? So the slide is telling you basically that. The first line create update index is doable with this key caching. Even a simple delete and select into the table you can do with key caching. Now when it comes to queries, that the DBA cannot do. Yeah, their key caching is not being supported for the DBA. All right. So that's it as a wrap up. So with the new version of Always Encrypted, sorry I don't have a demo here, but I also see that time flies anyway. So maybe it's good. We have the in-place encryption. We can say order table and set encryption on. You saw the command with online on. So we don't have to leave the box for that. That's the feature here. We can do like and range comparisons as of today, and we can put non-clustered indexes on randomized encrypted columns. And here's also the driver support that we have as today. All right, so I hope you understood that this technology really is super potential, but the reason why it's not suddenly enabling everything is because of this secure region. We cannot just support every command out of the sudden because every command now has to live in the enclave. It's a little bit like hackathon. Yeah? Like in hackathon, you had to first recreate every command to make it in-memory optimized compatible. In this case, it's like, well, we have the commands, but they are on the outside of the enclave. You have to bring those commands inside in the enclave, copy code kind of, but it's not that simple, obviously. This is why there is still some obvious limitations. Right? But I think we found a good compromise for the most useful and necessary operations, indexing, like, and range for a good start here. All right. With that said, question I take afterwards, I'll hand over to Ruud, who will talk to you about private link.
Fine.
number 5, right?
All right. Okay, great. Good afternoon, everyone. My name is Rohit, and today I'm here to talk to you about what's new in network security for Azure SQL Database. Now, before I even start, right, I just want to bring up SQL Server and just ask for a show of hands. How many of you have had to manage firewall rules where they have grown to such an extent where you don't even know who owns what? Good. And has anybody been brave enough to set up VNet service endpoints and firewall rules in the room? Okay, great. That's my audience. So I'll just start by bringing up a slide here. So this is what we have today, right? At the very high level, there are these 3 network access controls. And if you want to see me talking in detail, the short link has some videos that Colin and I did on YouTube around these. Needless to say, let me start by showing you what's new. So what's upcoming, which is we have this feature called private link. And the basic idea here is private connectivity to your PaaS service. Let me show you how that works in practice, right? So assume you have a SQL server and you have a virtual machine that's inside of a VNet with its private IP address. So the 10.1.5 is the private IP. And you want these two to communicate with each other, but over the private address space. And just to make it a little bit more complex, let's assume these are in 2 different regions. So this is where private link comes in, and it creates this link between your virtual network and the SQL database. And then it assigns one of the IP addresses from your virtual network to be the endpoint, right? So now you may ask me, okay, why should I even care about this? So one of the things that you get here is you get a truly private endpoint for Azure SQL at the server level. So below that server, you can have any sort of database. You can have data warehouse, you can have serverless, hyperscale, you name it, right? This hopefully solves your firewall rules problem because you can now connect from on-premises using ExpressRoute or VPN. It gives you good data exfiltration protection because that private endpoint that you see is going to map to only one logical SQL server. So if that's compromised, then you know that it's only linked to one server versus when you come in through our public endpoint, you have a shared control plane. And then again, it's an IP address at the end of the day. So it can be part of your network monitoring story, right? It's in preview for these services and many more coming in the short term. Let's briefly go over what is a private endpoint. And I'm showing this because that's what you'll need when you set this up. So private endpoint basically consists of 3 things. Number 1 is the private link resource, which is a fancy way of saying what is my PaaS service that I want to link to, right? It is SQL database storage account today. There are many more coming as you go forward. Number 2 is what is the virtual network and subnet where I want that IP address or the private endpoint to be created in. And number 3, this is kind of interesting, is this DNS integration. So when I associate that IP address with my SQL database, I need some sort of DNS lookup to happen when I am trying to connect to my database within the VNet. So that is accomplished by this private DNS zone. So bottom line is when you are inside of that Azure VM and you try to connect to your server.database.windows.net, this does the DNS lookup for you and maps you to the private IP, right? And with this, I'll go to a demo. Now, I'll be frank, I thought about showing the demo live, but one of the reasons I've recorded this is because the deployment options takes a little bit long. And plus, this gives me a little bit more flexibility in showing you some key aspects. So the demo is pretty much the same thing that I showed you earlier, which is I have my, okay, hang on, not good. Okay, this is okay, interesting. Okay, so I have a SQL database in West US and I have a client VM in the East US, right? Same scenario we talked about. And the demo is about how do I connect these over the private link. So as I just showed you, my SQL database is completely empty. There's no firewalls or anything, so no public access. And let's go switch over, look to the client VM. It has these two IP addresses, the public and the private. And I ideally want to connect to SQL database over the private endpoint, private IP address of this VM. Now in this screen, I'm logged into the VM and I do a NS lookup, which is DNS resolution for my SQL database. And you'll see that this points to this 104.42 IP address. So this is the shared common control plane that we have in each region called the SQL gateway. And this is where your logins will go to by default when you try to connect from outside Azure, right? Now, let me switch to Azure Data Studio and try to log in. Right? And while this is going on, anybody wants to take a guess as to what will happen when I try to log in here? Any guesses? Should I be able to log in? Yeah. So somebody said it. So I'm going to get this error this screen here. I mean, SSMS used to throw an error message, but now you get the same there as well, saying that, hey, I recognize that you're trying to come in from this IP address of your VM, but this is not in the firewall, right? So you need to whitelist or add this IP address there. So I'll cancel out, and now I'll show you how I switch to connecting over the private IP space. So right now in the portal, we have this private link center. This is where you go to configure private endpoints. I have several configured for some storage and SQL accounts, and I'm going to add a new one. So step one is basically to pick the resource group. I'm going to pick the same resource group that has my client VM. Doesn't need to be in the same, I mean, again, this can be totally decoupled, right? But for simplicity's sake, I'm keeping the private endpoint and my VM in the same VNet. So next step is to basically say, as I said, what is my private link resource? So here I can link to a SQL Server in my subscription. So I pick the SQL Server, click Next. Now this third screen is interesting because this is where I choose the VNet and subnet where I want to create the private endpoint. So I have a VM subnet and I have a PEC subnet, which is for my private endpoint. So I'm going to create it in a separate subnet, but within the same VNet. And then I'll go with the default option for the DNS zone, right? And then I click Create. And usually you'll say, once you click Create, this is the part that takes several minutes, right? And then you end up here. So from here on, I can switch to the portal and show you what all got created. Any questions so far? Is it making sense? Yes.
Set up a link between subscriptions as well?
Yeah, I'll go. That's my wrapping up slide. So that's a hold that thought for a minute. No, it's perfectly fine.
Take my money.
Yeah. So as I said, right, what gets actually deployed in this resource group when you do this? Number one is this private DNS zone. This is private DNS zone is now GA in Azure networking, and it's a networking feature. And this makes sure that in the scope of this VNet, whenever if you do an NS lookup, I'll show you, it resolves to this IP address, right? And we also create this private endpoint. Right now, when I created, it's auto-approved, but going forward, the plan is to have some sort of a separation of duties around this, where a network admin creates this, and then the SQL admin can approve or deny this creation, right? And now let me go to the VM itself. So the NS lookup, when I do it from here, okay. So you'll see that the NS lookup now points to this private IP address. right? Whereas earlier it was going on the public IP address space. And then I'm going to hit connect, and the choose adventure works, connect. And I just connected without having to do anything, right? And just to show you this is for real, I have some BCP workload that I'm going to start here and run this query, and you'll see that I'm doing reads and writes, but the client net address, which is where I'm connecting from, is the private IP address of the VM. So everything here is going through the private IP address within the Azure backbone, right? So that was kind of the demo. And I'll do one last slide to kind of wrap this up, which is how do you use this thing? So the idea is, this will be your default setting where you will typically keep the firewall blades empty to have no public access and create a private endpoint within a VNet. So far, so good. The demo that I showed you is, let's assume for simplicity that my client is Azure VM. And the demo that I showed you is this one, where the Azure VM is in the same VNet. So nothing special here. The power of Azure networking allows you to peer VNets. So basically, you can have a client in a peered VNet that can connect to this private endpoint, right? And you can add an Azure networking component called a VNet gateway, which then allows you a couple more interesting scenarios. Number one is you can then connect from on-premises using ExpressRoute or VPN. And another cool scenario is you can do this VNet to VNet connection, which means your client could be in a different region and also possibly in a different subscription. So that's the real power of it, is where I have the endpoint versus where my clients are versus where my SQL database is completely disconnected. They can be in 3 different regions. And all this is coming to you through the magic of Azure networking. So, sir, does that answer your question about? Okay. All right. I think I'm done. Yes.
So I'm guessing you're probably going to need to do a DNS thing for on-prem.
Yes. That's the one thing that we are finding out right now is when you come from on-premises, what happens is you can reach the IP address, right? But then you will be able to, the FQDN resolution to the IP address happens within the VNet by the private DNS zones. But yeah, coming from on-premises, that's a very good catch. You'll have to set up a DNS server, or there's also a possibility of extending that DNS zone to on-premises as well. So
And that was just the IP address, or
IP address
actually use the hostname?
is not supported by design, so it's, best practice is to connect by hostname. Thank you. So I'll hand over to Mirek.
Could you? Thank you. Hi, I'm Mirek, and I'll be talking about the migration. How many of you are using today Azure Active Directory? Good. That's good, because the Azure Active Directory is the repository that Microsoft is going forward for cloud, and there's no way to step back. I even give a warning that at certain time the SQL authentication will be obsolete. No, not yet. So I'm not announcing it. How many of you are using managed instance? Good. How many of you are trying to move managed instance with Windows authentication to, SQL on-premise or SQL Server with Windows authentication to managed instance? What's your experience so far? Okay. So let me talk about it because this is a interesting topic, and the reason why is there's a problem when we have a Windows notation in SQL Server, and then we have an AAD notation that's supposed to emulate Windows, but it's not as easy as it looks like. So let's recap on what we have today for managed instance. We allow today for managed instance to create Azure Active Directory logins. And these logins are regular logins in MasterDB for Azure Active Directory users. Why do we need logins? Because that's the way how you get the full control over the entire instance. So we allow this, and with the GA that we made, we allow right now a couple of more specific features there. One of them is this, the Azure Active Directory admin has a login, and then it has a sysadmin permission and can create other logins and give different permissions, including sysadmin. So we are in parity with the SQL logins. The second thing is the users can be created in the database using the Azure Active Directory users logins, and these are the Azure Active Directory users. So I can create a user, AAD user with AAD login, and that's what the diagram is about here. Why are these logins important for the migration? Because the majority of scenarios that we have today is that the on-prem is running on the Windows authentication, and you have logins, you have Windows logins, you have Windows groups, and then obviously you have Windows users. So what we help here in the migration process is offer two possibilities. One option is, I call it the highway, which is the DMS, data management, data migration system that you can use, and it practically migrates logins and users to managed instance. But then for those who need special scenarios, and trust me, in the complexity of the domains, these special scenarios are coming. You can get the engine support for this. So what are the prerequisites for the migrations? Well, first of all, if you want to migrate from on-prem to managed instance, you have to federate your Azure Active Directory. So you have to make sure that the AAD is sensitive to the Windows users. Second of all, you have to enable Azure Active Directory admin that allows simply to connect to AAD. Then there's a restore process. My colleagues from Serbia, Mladen and Jovan, they had a whole session how to do a restore based on the backup restore. So you back up the on-prem part of the database, and then you restore it on managed instance. That's a known technology, well documented. And finally, if you want to use the engine support, the DDL statements, you have to move logins on your own. We support it for users and user permissions. So these are this is the syntax that we use to migrate Windows users to Azure Active Directory users. And if you look at both syntax, one is for the user, one is for the group, there's no change syntactically, but there is a semantical change that we add. Like you can give the on-prem user, in this case, this is on-prem domain, Windows username, which is typical a Windows notation. And then we move this login, or we map this login to the AAD login, which is Windows user at domain.com. That's the difference in the mapping. And the same you can do for groups. Obviously, the assumption is that these groups and users exist on both sides, in AD and in AAD. Go ahead. So this is the question how we solve this problem in AAD. You see, and this is a problem, what I was mentioning, when you synchronize the forest, and it's outside of SQL. This is the AAD synchronization. How do you make sure that you don't have collisions in this? And there are different scenarios in this that's documented. So it's a kind of, we are, on our level, we are the consumer of what is in AAD. And whatever is there, we support. And as I indicated here, the roles and permissions are inherited. So through the syntax, if you define the roles for the users and permissions, through this remapping, we have it. The second one is if the user doesn't have a login. There are so-called Windows users without logins. How do you migrate these guys? And this is a syntax that allows to do it. This is now the syntax change in the alter index or the alter user because we are adding from external provider. And the AAD is Azure Active Directory is smart enough to look at the Windows user, and I show you in a moment how, and convert it to Azure Active Directory user. So after this conversion, I'll have a demo on it, you will see that the user was properly converted to AAD user with permissions and with roles there. One thing that will be coming, and this is the troubleshooting, and you already mentioned it with Forest. You see, all this issue related to duplicate groups, collisions, that needs to be prepared as a prerequisite for this migration, and this is the prerequisite in AAD. That needs to be obviously tested properly, but sometimes there will be issues that for some reason the user is not there in AAD. So what do we do? And we have one specific identifier that I like to show you that is walking through the whole cycle. And this is the on-premise security identifier that originates in Active Directory. So when I have this Active Directory identifier and I create the Windows user in SQL, we take this identifier and we convert it to SID. When we migrate this to Azure Active Directory, this identifier goes with the migration or with the synchronization over there. It's still there. Azure Active Directory is using object ID, but it has this identifier precisely for the reason to make sure how do we deal with potential collisions, with potential issues. So with this, let me jump jump to the demo and show you a couple of things. If you have questions until now, just go ahead, sir. These are the new features. The new syntax is new, and the syntax that you've seen here, semantical change, is also new. Well, the problem, okay, let me repeat the question. The question is, for group accounts, is it support for SQL DB or is it support for managed instance only? So the answer is, from the feature standpoint, it doesn't matter. The problem is we don't have today an easy mechanism to bring single database into the SQL DB, single database from SQL on-prem into SQL DB, because backup restore is not allowable. So obviously you can use the migration, the DMS, the data migration system, but the thinking is in the future to allow it. This feature already allows this because for the encapsulated for the users without logins, it doesn't matter if the Windows user is there. I can convert it. No, it applies already. For managed instance. For managed instance, yes. Not for SQL DB. So let me move to, I think I've got 4. So here's the demo. I'm connected to SQL Server, okay, a regular SQL Server. And I said that we are going to do the migration, which means I'm creating a couple of necessary objects there. The logins, the users, and give the permissions for the users and give roles for the users. So let me quickly do it. And I already did this. So you can see right now that in master, I have 3 logins. The first one is my admin. And these are the 2 logins that I will be dragging with me, which is the PM logging and the migration. Migration, by the way, is a group, okay, and it contains users. So it's created there. The second part is to create users in the database. So I have a database migration, and if I see what users that I created, I have here 4 users. 2 of them are users with logins in master, and this is this one, and this is the group. And 2 of them are login-less. They are contained users. They are created for Windows without logins. Now, I can define a role, user migration role that has connect, select, view database state, view definition, and I can assign it to a specific user or make this user a member of this. So I do it, and let's see what we have here. So you can see that this migration role, user migration role, that the user PM, Mirek SPM, is a member of this role and has all the permissions that were granted there. For the group, I can make this group a DB owner, and I did this. So if we select right now to see if this group is DB owner, you will see that it is. It has a 1, which means this particular group is the DB owner for this particular DB. The reason why I'm doing is I'm creating this little framework or this little structure that I will be migrating to managed instance. And then finally, if we check all the permissions that we have, then you can see the different users here that are there, and the permissions for roles that are indicated here. Like you see that the typical user, when created, has a connect permission. This is a default one. And then we have all these permissions for the role. And then we go back and see other users as well. So that's the site that is the SQL on-prem, that is the SQL Server site, okay? Now what's happening is the following, and I'm not going to go step by step. It was explained today during the session on managed instance. But what you do is you take a backup of this database for SQL Server, and you restore it for managed instance. And you use the Azure storage to do this. And there are a couple of steps that I needed to make this restore. So you can restore this database. As I said, we don't migrate logins. So if I want to have these users with logins migrated, I have to create these logins manually in master. And this is, I'm right now in managed instance. And you can see that I have 2 logins there I created. One is for the user, that is the user that exists in AAD, and one is for the group that exists in AAD. And they correspond to user and group in Active Directory. For the database that was migrated, or that was restored, because I restored this database and managed instance, I also I see the following users in this database. So if you look here, you see that this is the database at managed instance that contains the Windows users and groups, and one group. These users and group are there, but they are not accessible. You cannot connect to them. There's no way to do it. You have to remap this. You have to remap their Windows their Windows notation to Azure Active Directory notation. And to do this, we use the syntaxes that I show you, which is the alter user. Now you can see that in this syntax, I have a user, a Windows user, and I want to remap this Windows user to this login, or to the user that is using this login. And this is the AAD login. And the same here, I have a Windows group that should be remapped to the AAD group that exists in AAD with these logins. So let me do this. And do remember here we can see that this and this one, they are the Windows users. If I run this command, you see that they have been remapped to the Azure Active Directory users. I have the external user and I have an external group. So now let's see what about the permissions. The first user, the Mirek SPM, was a member of a role. So let's quickly see what's there. So if I do this, if I run this select, you can see that this user is a member of the role that was also used, that was kind of came with the migration itself. And if I continue, I check, for example, the migration group. Do you remember it was a DB owner? So if I check this, I still see that it is a database owner here. And if I check the permissions, I can see that these permissions are similar what we've seen before. And you can see that the role, that this migration role has the permissions as connect, select, view, and so on. And the other users have the permission connect. Now let me convert the two other users that are still there, two other Windows users that do not have logins. So I'm using the syntax that I show it to you. And this is the syntax with the from external provider. And let me do it user by user. So this user was converted without any problem. And I show you in a moment that he's really the AD user. When I do this for this guy, I get an error. And it says that cannot find Azure AD principal mapping to Windows principal. There's a mismatch somewhere in the chain, and we cannot convert. And that may happen in the future. I like to drill down into this. So, but before I do it, let's recap here, and you can see that finally we migrated 3 users. The PM user, the group migration, and the one which was the alias test, which is the Windows or login-less user. So let me jump to a debugger to see what's going on. How can I debug it? And I told you about this on-prem security identifier and the seed. So we need to go back to we need to go back to SQL Server. So now we are back in the SQL Server, and I'm trying to get this this on-premises security identifier. There's a small function that I wrote that gives the seed and brings you back the on-premise security identifier. So let me run the script, and you can see, I'm almost done. You can see that we have 2 identifiers now. This is what the identifiers, what they look like. and they are in AAD, and they are in AD, the same. And you can see that for the guy who was the alias test, the identifier is 1151. For identifier that failed, for the local, there was 2124. So let's jump quickly to the PowerShell. And this is the 1151 that should work. So this is the get user function, the PowerShell AD user. With the filter, I'm looking for the command on-premise security identifier with the string that is here. So you can see I get an object ID and I get my alias, which is mirec_s alias test and so on. So this user exists in AAD and thinks did work. If I do the same for the other guy, 2124, you see it's nothing there. So what do? I jump quickly at the end to AAD. So this is my AAD. And you can see that this local, this mirec_s local doesn't exist here. So no surprise that it cannot convert. The system is smart enough, does not allow to create a user that doesn't exist in AAD. How this potentially could happen? Well, I can tell you how I simulated this. So there's a synchronization process between the AD and AAD, and I stop it. And I add a user to AD, and it was not in AAD. But in the future, different thing may happen. So this is one of the potential that user can do itself without even involving CSS or involving us. Okay, with this, I like to thank you, and I give it back to Andreas.
Data classification. I have like 12 minutes, depending on your flights, I guess. So I want to quickly introduce this new feature that we now G8 in SQL Server and Azure SQL Database. The idea is, and I usually start off this talk with, well, who of you knows exactly what data you have in all your SQL servers? I know, I did that on purpose. I want you to look at me and listen to me. Okay, now you're awake, cool. So who of you is absolutely certain you know all of my data? I know I have this database and there's some classified data. Who knows exactly what kind of data he has anywhere in your environment? Everybody totally certain? Pretty certain, right? So it's usually about like 5% max of all, right? It's hard to say I'm 100% certain, but some are. Anyhow, so it is an issue, and that's where we have this data classification feature coming. Or it's there now. So basically, the first step is to figure out what data do you have across all your database and all your servers, and that's the discovery step. So it's actually a different feature. It's data discovery feature. There is an algorithm, or a very simple algorithm today, basically a pattern matching on your column names, trying to guide you which databases have columns which may contain passwords and whatever. Yeah? Obviously, pattern matching, we are looking for strings that contain the word password or something, let's say credit card, credit history, etc. That would be then another type of information. So based on this information, we suggest you certain labels and certain classifications. So we have two things. We have an information type, like it's credit card information, plus you have a sensitivity label that would be something like classified or sensitive or top secret, etc. Yeah, credit card information, top secret, and maybe just a credit note, yeah, credit history, just secret. Yeah, so it's two types of metadata that we can give you. And the next step is obviously to store this information, and it's going to be stored with the database. That's the classification step. So discovery and then classification. Once it's classified, it's actually part of the metadata that will be created when, or that is flown from the query processor when you execute a query based from a table that contains classified data. So let's say you have a table classified with certain columns, credit card information, classified secret or confidential. This information will be passed on actually inside SQL Server, inside the query processor. So for example, if you create a view on top of that, it will still contain the information, hey, this column, which actually comes from a table, is classified XYZ, in this case confidential. And we even pass it outside, so it's part of the TDS protocol. You can even get it in your application. So we actually have a POC where we are showing how to use this information in Excel, and based on if it's classified or whatever, we don't show it to the end user or exit out, whatever. It's up to you basically to decide what to do with this information. So you can classify your data. That's the big step here. And the other part that this enables us, because it's part of metadata, when somebody selects from this table, we also have the ability to make this part of the auditing that we have. So we have auditing, and we have a new column in auditing that shows you somebody accessed data that has a certain sensitivity label. Like he accessed data that is confidential / top secret or whatever you're using. All right? And because it's now in the audit log, you can also filter that and say, well, who over the last weeks has ever accessed data that's actually confidential? Is it valid use case, or is it maybe too much? Yeah, so you can say, figure out, okay, he was always just using single rows and not the whole table at least. So if he's using the proper application, he should only see one customer at a time with some information. But maybe he was just running, give me everything from this table. That's probably not the use case that's allowed. So you can figure this out from the auditing. Just look at who has accessed sensitive data and decide if this was a correct usage or not. So that's the step that we enable there. Yeah. This last part here is basically saying that in Azure SQL Database, all these labels that exist, they live in Azure Security Center. That's where you predefine them. So the tenant administrator basically is the one deciding which labels can be used throughout your organization. All right. Okay, so I mentioned auditing, and I'm just going to jump into the demo on that. All right, so this is my SQL database, wide word importers 3. We have under advanced data security here in the security tab, we have those 3 things: data discovery and classification, vulnerability assessment, and threat protection. The first one is the one that's quite empty here. It's fresh, this database. There's just some recommendation. Let's see what that is. So I'm going to click here. And well, there's nothing done yet, so it's the same picture as in front. If I click on classification and take this blue bar here, I will see some suggestions. So this discovery step is now being done. Basically, it has discovered some names where it says, okay, bank account, number, code, etc. This sounds like banking information, and maybe you should classify this as confidential. Versus full name, maybe it's confidential, GDPR related. So you have some variations there. So you can influence those labels that exist. You can create other ones. All right. This is just what has been assigned here automatically. So let me say I will use all of them and apply it. All right, before I save, I can even say, yeah, but maybe it's not just confidential. Let me just pick one example here. Let me take credit note reason. I put this as highly confidential. Change this to highly confidential. Something like that. So I can influence it before I make the final save here. All right. So this is the UI experience here in the Azure portal. So I'm saving it right now. If I go to the database, and actually I've done this before, I just ran this command before I started saving. There is a DMV in the database, and as I said, it's stored in the database. It's empty before the demo. Now, if I F5 this query again, it will show me, if I did it right, if it's finished. Should be database 3. Is it stored? It is stored. Hold on. Why is it not? Bang, bang. Wide word importers number wrong database? It's number 3, right? Not started. Come on. Doesn't look like it's being stored. What happened? It's obviously not stored, otherwise it would be here. But it's also not asking for saving, or something happened. I don't know. Yeah, that's always. When you have pressure, then that thing that used to work, just a simple save. Let me switch database, right? I have done this a few times before, so I have a database where I already did that. So obviously I tried to show it live. Big mistake. This one. So it's basically a copy of the same database. I just have done it before here. So it's also almost the same here, right? I have some highly confidentially saved ones. Now you see here the label ID is actually empty here. And the reason is this demo is already finished here and I overwrote it basically. So by default, when anything that comes from the portal will have this label ID, always the same. Right, you can memorize it if you wish so. Right, there is no deeper reason here for that. Right, what I did basically, the first step is you can obviously join it to make it a little bit more understandable. So which table are we talking about? Credit note reason, that's the one that I changed to highly confidential. But for some reason the label is gone here, the label ID is gone. And that's because I'm showing you here the commands that I can run in T-SQL. So anything that the portal is doing, adding those labels, is basically just T-SQL, and that's the label. That's the command that was being run. So it adds a label to the column called whatever, an information type. And as you can see, I'm not mentioning any GUID here, and this is why after running this command, and I can run it again, it will not have the GUID anymore because I'm basically omitting it. So this is showing you can also label it from the database. And it's up to you if you want to use these GUIDs or not. Why would you want those GUIDs? They are basically the means of, if there's another vendor basically providing you with its own mechanism, discovery mechanism, and he wants to update this, they may want to use the GUID to find it in their own catalog, right? So just as us doing it from the Azure Data Catalog. But if I'm doing it ad hoc inside a database, I have the permission, obviously, here. There's a certain permission attached to it, and I can override it with any GUID. It's not like prevented at this point in time, right? But I can obviously also use a GUID, right? That's what I'm using here, so I can kind of repair it if I wish so. So go back and run the command, and I see, well, there was one line that I missed, but the other one is now with a GUID. So just showing again. So what I do here is add the label and label ID to one column alone. The command above that is an example where you can actually, so we enable it basically to be done in batches. You can add the same label to multiple tables, columns at the same time. So this command combines actually two different tables with two different columns, and they both get the same label assigned. That's the command, okay? You don't have to do it, but maybe it's sufficient for some scenarios. We also have a rank, that's a third information type, if you so wish. And I already ran the command. So this one here, the credit note reason, I have just taken the rank high. So you can also use this to make decisions based on that, right? So label, information type is more like, oh, what kind of stuff is that inside? And rank is to automate, maybe trigger off some further mechanisms. All right, my time is unfortunately over, but if you want to stay with me, I'm going to show you the last part on auditing. As I said, we have combined this in auditing. I can go view an audit logs. It's already set up basically. If I go to audit logs, I have the ability to view the dashboard. And I will see something like this. Yes, there was access to sensitive data, a couple of thousands selects or whatever kind of commands. Keep going here and I can see which principals have accessed which type of information in my database. All right, trainee Joe, highly confidential. Maybe that's not what he was supposed to do, right? So you would see it here. Yeah. And if I would click on this one, it would lead me to the Azure Log Analytics, where you can further play with it. So the target is Azure Log Analytics, which is also now in public preview, I think. Yeah, public preview. So this is the connection auditing, sensitivity labels, and log analytics for complex analysis of the audit logs. Yes? Yes, the feature also works on-prem. On-prem, you would not use the log analytics. You would put it in the normal audit log. So the demo would look a little bit different, but you would have the column sensitivity label as well. And you can query it, like after you put it in the file, you can also use this information as well. Yeah. Is this working with managed instance? Absolutely. Yeah. It's more like on-prem. Yeah. You have this audit, the audit which you put in Azure storage. This is a SQL Server 2019 improved feature. In SQL 2017, we had it already, but the information was not in the DMV that I showed you in the system table. It wasn't extended properties, and it also did not have the permission, a special permission for it, and so on. So it's improved over it. Yes? More questions?
If a customer has a work group set up, so all access to a work group, what shows up in the SQL audit log on 2019 on-prem?
If there's a work group set up, what shows up? You're talking about...
Windows work group, so all access to the Windows work group.
Oh, okay. This is basically the issue of what's the principal name. I believe the principal name is simply the group name in that case, and you would have to... maybe we even have the original login here. I don't know by heart, honestly. I have to double check on that. Feel free to send me an email. I've just put the last slide, but I will be here for question. Just if anybody wants to leave, I know there's some stuff missing here. Reach out to us. What's happening? Yeah, great. That would be our emails. Okay, more questions. Yeah. It's kind of makes sense, right? Yeah. So I can't really say anything on stage here, but we are looking at it because it totally makes sense. Yeah? To take this as the base of information to make the decision what to do with this data, right? It's highly confidential, makes sense to encrypt it, right? Yeah. So yeah, we are obviously thinking about something like that.